So, I will demonstrate ferromagnetic, similar to ferroelectric material, there how to get this polarization versus electric field loop. So, in magnetic material, ferromagnetic material, MH loop or BH loop is the characteristics of ferromagnetism. Similarly, for ferroelectric material, that PE loop is the characteristics of ferroelectricism. So, this experiment will demonstrate in our solid state physics laboratory. So, this the process we will use, the process or the technique we will use for this PE loop of ferroelectric material. So, basically that there will be two capacitors, parallel plate capacitors. Okay. They are in series, they are connected in series and AC voltage will be applied. Now, in one of the capacitor, the sample, our ferroelectric sample will be inserted between these two parallel plate. So, with sample, the capacity of this capacitor is C1 and this second capacitor, this basically known capacitor C2. So, known capacitor is connected in series with our sample capacitor. So, now the charge will be stored in capacitor 1, that is Q1, and in capacitor 2, that is Q2, and their corresponding voltage drop V1 and V2. Then you know that in case of resistance, when resistance is in series, and current is flowing, then what we do? We tell that the current is same passing through the resistance, but voltage drop are different, that depends on the resistance of the resistor. Similarly, in case of capacitor, so their charge will be same, when they are in series, charge will be same in the circuit, but voltage drop will be different. So, Q1 will be equal to Q2 and this is C1 V1, that is other one C2 V2. So, C1 V1 equal to C2 V2. Okay. So, C1 is known as I told, then V2 is measured. So, across this, what is the voltage drop V2? If we measure, then and V1, V is the input voltage. So, that is also known. So, one can find out V1, V1 will be V minus V2. So, V2 will be measured across the known capacitor C2, okay. And then corresponding V1 I will get V minus V2, since V also known is the applied voltage. So, C1 will be equal to, from here you can see this C2 V2 by V1, okay. C2 V2 by V1. So, V2 is measured, C2 is known, supplied, V1 also known from V and V2. So, we will get this value C1, we can calculate this value C1. Then when we will know C1 and V1, then we know the Q1. Okay. Q1 can be calculated equal to C1 V1. So, we know Q1 and V1. What is Q1? The charge stored in the capacitor, our sample capacitor, and V1 is the voltage across this capacitor. Okay. So, now this charge on the surface, basically Q1 charge on the surface of this, one side it will be positive charge, other side will be negative charge. So, it will form dipole, okay, electric dipole. So, P is basically, it can be electric dipole per unit volume, or it can be electric dipole per unit area. So, here we have taken polarization is equal to charge per unit area, okay, because here it will be formed, one side is plus charge, other side would be negative charge Q1. Okay. So, one can find out the P polarization Q1 by area, and electric field from V1 we can calculate V1 divided by thickness of the sample, So, basically we are using ferroelectric sample between two capacitor plate, okay, and one known capacitor will be used. Now, V, that AC voltage will be applied in series. Then from here I told you we have to measure basically this voltage drop V2, and we have to know this V, then we can get Q1 and V1. So, from Q1 and V1, from the known area of the sample and thickness of the sample, we can calculate the polarization and corresponding electric field. So, for different electric field, what is the polarization that we want to measure? Then we will plot P versus E. So, if you want to see the hysteresis loop for ferroelectric material, so we have to start from the maximum electric field and go to the maximum negative electric field, and again go back to the maximum positive electric field. So, with some step of electric field, we have to take data and then plot, then we will get this kind of hysteresis loop. Okay. So, from this hysteresis loop we can find out what is the saturation polarization PS, what is the saturation polarization PS. Okay. So, that value corresponding, that value will be PS. Okay. What are the remanent polarization, that is PR, okay, and what is the coercive electric field EC, that also you can find out. Okay. Now, if we want to do the experiment as a function of temperature, then what we want to know? We want to know the what is the saturation polarization PS, how PS varies with the temperature. So, PS versus temperature we can measure from. So, every time we have to take this hysteresis loop for each temperature, and from there one can find out PS, okay, and that PS can be plotted as a function of temperature, and then one can find out the transition temperature from ferroelectric to paraelectric phase transition, one can find out. Okay. So, so different kind of information so one can get from this experiment, and I will show this experiment in our laboratory. It is the computerized experiment, but I will explain what are the parts in this setup. So, here basically we have yes, I will show sample. So, here this is one electrode, I think power is not given, yes. So, this is one electrode, this is one electrode, and one tablet type of sample is placed here. So, we have used this here silicon oil for uniform heating of the sample. So, here this is one electrode, this is one electrode, this falling on top of the sample, okay, and bottom of the sample on this platform, it must be isolated from this other part. So, So, here is the one connection and the other connection is this one. Okay. So, from two electrode from bottom and from top. So, these two. So, electric field or voltage will be applied through this. Now, this one has gone in this box. Okay. So, this two wire has connected with this box. Inside this box, there is known second capacitor is there. There is second capacitor, known capacitor, as I told C2. So, this connection, this has gone to like inside this type of connection is there. Okay. So, this is our sample connection, this two wire has come. Okay. So, one has gone to this AC power supply, it is inside, and other has gone to that known capacitor C2. This is inside the box and this other. So, this circuit is completed. So, this circuit is completed. Okay. So, it is in this box. Now, what is the experiment we have to do? So, here we have option for setting of temperature. This is the temperature one we can set at different temperature. We can do the experiment. So, here it is at present at room temperature 22.6 degrees centigrade, it is a room temperature. Okay. We have not applied any temperature. So, we will do the experiment at room temperature. Okay. So, basically what we have to do, we will apply different electric field, means different voltage, we will apply different voltage V1, right, and corresponding we have to get this capacitor value C1, and if I know the C1, as I told this C1, it will be, so C2 is known and V2. So, basically I will apply from here, I will for changing the electric field. So, basically I have to vary here V1 should be different, okay, for a particular V1. So, V1 how can be varied? So, this V can be varied, this V can be varied. Okay. So, corresponding V1 will be different and V2 will be fixed. Okay. So, we will vary V1 varying the V, and we will get basically Q1 and corresponding P different P. So, basically we are varying V and thus we will get P at different electric field. Okay. So, that can be done manually. So, manually I will vary the incident input this AC signal, input AC signal, okay. And then I have to note down the value of V2, okay. So, then rest of the part I should calculate and find out the electric field and P. So, here, so whatever the manually we can do, so here that computer programming will do this job. So, this is the computer, we are collecting this data through this computer. Okay. So, in computer all information is given here. You can see that thickness of the sample is 1 millimeter, that we have to give information to the computer. So, what is the thickness of my sample? So, this is 1 millimeter. What is the area of my sample? This is 12 millimeter. So, what is the variation of the field I want? So, kilovolt per centimeter, that electric field variation whatever I want. So, maximum electric field up to 10 kilovolt per centimeter, that you can select depending on your sample, you can select 5 kilovolt per centimeter or 100 kilovolt per centimeter. So, one can change here, and so maximum field if I give, so it will just vary from plus maximum to the minus maximum to the again plus maximum. Okay. So, if I just define this maximum field, so plus maximum field to minus maximum field, and again it will go back to the plus maximum field. And here number of cycles means I am in programming, I am telling that okay. So, you measure this loop 10 times, okay, then take the average of that one and plot. So, that is why here meaning of the number of cycles, okay, how many cycles, and here if their ramp rate, here you can see ramp rate for temperature. As I told, we are not changing the temperature, we are not using the temperature, room temperature if you do the experiment. So, this part for variation of temperature if we want, so this part one should use, and this part is basically for P loop, we are interested for P loop. So, we will do experiment in this condition. This is pyro measurement, means temperature variation, varying the temperature, this measurement, and this is a fatigue measurement, these are varying the so it is not temperature variation, varying this electric field we are measuring. Okay. So, so this in computer basically we have to give information, and here internal capacitor I told that in that box there are known capacitor C2 capacitor. Okay. So, that is the here it is written internal capacitor. There are three options, there are 3 options 10 micro ohm, 4.7 micro not ohm farad, 4.7 microfarad, 1 microfarad. So, you can choose one of them. So, we have chosen 10 microfarad, okay. And internal resistance, that is not coming in our calculation, but shear circuit basically there will be internal resistance also. So, one can choose. Okay. So, whatever in internal the circuit is there the C2 capacitor, this we are choosing 10 microfarad, okay, that is coming in our calculation, and yes. So, this is the frequency, this frequency of this internal resistance, frequency, PG again, wave type, sine wave or triangular wave. Okay. So, one has to choose this one. I think this frequency your whatever voltage I am applying, okay, this maximum field whatever I want, for that I have to apply voltage depending on the thickness. So, it will calculate this field. So, I have to give this some frequency of the field I am using. Okay. So, all this information we are putting. So, one has to know about the what are the things in the program for details use of this instrument. So, we do not need that much at present. At present what I want to know? I want to know that how to plot PE loop, how to plot PE loop of ferroelectric material. Okay. So, instead of manual reading, so computer is doing our job very fast, it is very fast. So, here I have to, here if I just click this one, apply, here it is showing parallel capacitor is 10 microfarad, okay, whatever we have chosen 10 microfarad, and parallel resistance value we have that is 10 kilo ohm. So, whatever value here, so it is showing. Because there are other options also, which options we have taken, just it is telling us. So, then we will put OK, and okay, I think I have to choose P scan, and this OK, for it will take data for 40 seconds. Okay, yeah. So, I think it started the experiment. So, I asked for P loop between this maximum field 10 kilovolt per centimeter, and it will take 10 number of cycles and take the average. So, each cycle it is basically varying the electric field. Okay. How it is varying, that I told you, basically how computer programming itself, it is calculating the electric field from the voltage V1, okay, and how it is getting V1. So, V minus V2, because it is measuring V1 V2 across the C2 capacitor, known capacitor. Okay. So, it is plotting. So, when we will do experiments, so manually we have to take data and we plot. So, for one loop it will take at least maybe 1 hour, but here this computer is very fast, it is doing the things within 40 seconds, it is taking this, I think 10 loops, it is like this. So, it is plotted, you know. I think this data is taken here. Also it is giving what is the PR value, this is the PR, okay. It is giving PR, P maximum value it is giving, but here we can see that it is not saturated, okay. So, to get the saturation value, even we need higher electric field. So, I have to change this field, it is maximum value 10 kilovolt per centimeter I have given. So, this we have to change, say we have to give for 20. So, then we can get the, maybe we can get the saturation value. So, anyway, this is just one can play with these parameters and find out the PR value, PS value, saturation value, okay, and then EC value, EC coercive electric field, EC value. Okay. So, this is for at room temperature. Now, for different temperature, you can get this value, okay, and plot it. Okay. PS, if you plot PS as a function of temperature, so then you will get this type of variation of the P with temperature. So, this basically one can find out the Curie temperature. Okay. So, but in computer we have this option for doing the experiment with the temperature. So, that means it will vary the temperature. Okay. For each temperature it will measure the pH, PR, okay, and even EC. So, all these parameter then it can plot as a function of temperature. So, I think I will not do that here, mainly I wanted to show you this how P loop measured, although it is computerized, but manually also one can do, though it is time taking. Now, this is also good, this when you want to measure as a function of temperature, then this we use this option pyro measurement. Pyro means temperature. So, with temperature we can study, and pyro measurement another. So, if sample is have the pyroelectric property. Pyroelectric means with temperature how polarization changes. Okay. So, that is used for making device, this for as a thermometer, pyrothermometer. So, that one of the application of this dielectric material, pyroelectric material is called pyroelectric, although it is dielectric. Okay. So, its response to the temperature, response of the polarization to the temperature, and it is sensitive. Some material shows the sensitive variation, and that is used as a temperature detector. So, temperature is basically used as a temperature sensor. So, thus we have this type of sensor in reality we use as a thermometer. In our research lab generally we use this type of thermometer where direct contact with the sample is not possible. So, this from radiation of the sample it takes the heat, and it can from this heat itself, from this radiation itself, it can tell the temperature of the sample position. Okay. So, this is one nice experiment, P loop similar to BH loop. That is what I demonstrated here. So, I will stop here. Thank you.